Okay, so in this screencast, we'll do a few examples that will help to illustrate the integral test. And so, if I may, let's consider the series, the sum from 1 to infinity of n over n squared plus 1 quantity squared. The question is, does this series converge? Well, to know if this series converges, we consider the integral from 1 to infinity of x over x squared plus 1 squared dx. Well, how do we do that? Well, that's a u sub, because du is hanging out up here, right? And so this turns out to be 1/2 the integral from 2 to infinity of u to the negative 2 du. And I don't have to do that for you. This integral turns out to be 1/4. And this is a number. And because this integral is a number, then this series is also a number. The integral was a number, so the series is a number. Well, what about this one? The sum, as n goes from 1 to infinity, of 1 over n squared plus 1. Does that series converge? Well, if we consider the integral from 1 to infinity of 1 over x squared plus 1 dx, the answer is certainly, because the antiderivative of 1 over x squared plus 1 is inverse tan. Oh. Limit as b goes to infinity of the inverse tangent of x from 1 to b. And that's inverse tan of b minus inverse tan of 1. Well, what happens to the inverse tan graph as b gets large? Well, that's pi over 2 minus pi over 4, and that's pi over 4. And what's important about that is that that's a number. And because this is a number, this integral is a number. And because this integral is a number, then this series is a number. Well, let's do the sum from 1 to infinity of 1 over square root of n plus 4. The divergence test doesn't apply here because you take the limit at infinity and the terms get closer and closer to 0. But as we've seen, it's possible for terms to get closer and closer to 0 without the sum settling down. So what happens in this case? Well, we take the integral from 1 to infinity of 1 over square root x plus 4 dx. Well, what's that? That's the limit as b goes to infinity of whatever that antiderivative is from 1 to b. Well, this is a u sub where we're dealing with u to the negative 1/2. And u to the negative 1/2, well, that's 2 u to the 1/2. So that's the limit as b approaches infinity of sub in the b and sub in the 1. Well, what happens to this as b gets large? That goes to infinity. This is not a number. And because this is not a number, this integral is not a number. And because this integral is not a number, this series is not a number. This series diverges. It grows infinitely large. I hope you are able to see the integral test in action. It is very important to us.